Bismillah ar-Rahman ar-Rahim. It's already started, so that's good. You guys can see my screen now?
Yes.
Okay. Bismillah ar-Rahman ar-Rahim. So last week we started talking about the architecture, and we started, basically understanding the fundamentals of this. And we looked at what is an architecture. Let me very quickly recap so that we are on the same page before we move on to the material for today. So we said that architecture is an important design phase, and because as part of your design, you take so many different design decisions. Some of them impact the structure of them, which we classified them as principal design decisions. And we said that architecture is basically a set of principal design decisions. Then we also had a look at another definition, which was a more detailed definition, the Mary Shaw's definition, where she says that architecture is a collection of elements, and those elements interact with each other, and then you have certain patterns, and you have certain constraints. So we realize that this is probably a more clearer definition for architecture, that you have, and then we started using word that these elements are actually components, and then these components interact with each other, and then you have certain styles of architectures, and then you have certain rules or constraints you need to follow. We also, if you recall, we also talked about that architectures have temporal aspect. This means at a given time frame, you only will have one architecture, and you will also, have something called prescriptive and descriptive architectures. The prescriptive architecture is the one you basically design, and the descriptive one is the one you basically implement. And of course, in a very ideal situation, you will like the prescriptive and descriptive to be the same. But at a given time, you only will have one, and as a designer, as an architect, we like to in our documentation to be consistent, so on and so forth. So this is what we discussed so far. Uh, Again, just before we start today's lecture, I just want to make you sure that you have this clear understanding that architecture consists of elements, and those elements interact with each other, and you have certain patterns, and you have certain constraints you need to follow. So far, so good?
Yes.
Okay, so this was something we discussed earlier, and I thought maybe it's good to have a bit of quick recap on our concepts. Now, I think we did talk about this component as well, but we can start from here now. So, as we said a moment ago, uh, you have certain elements of your systems which encapsulates the processing and the data of the system. And we technically call them software components. Software components actually, encapsulates the processing and data in your system. And we formally defined software component as something which encapsulates the functionality and data of the system. It restricts access to its internal functionality and data via only interfaces. So you can access them via interfaces. And because you have interfaces, you will have certain explicitly defined dependencies between them, right? So you will have a component. This component is self-contained, encapsulated. Its internal functionality is not revealed to outside world, except only well-defined interfaces. And of course, you have certain, because you have interfaces, you will have some explicit dependencies or preconditions for you to be able to access data back and forth from this component. C1. We also said that the other day that, and we use the word typical to just cover different possibilities. So components typically provide application specific services. So these components you write for your application are usually written for your application. They usually or typically written for your application, and hence because they will be showing the functionality of the system, which means at the end of the day they will be reflecting the requirements of the system. So these components are written according to your requirements, according to the functionality, the feature required by your system, and hence these components are typically application specific services. Everybody is clear about this? These packages, these components, these plugins. Okay. So some show of hands here. Are you able to visualize what a component is like? Thank you very much. Thank you.
Doctor, what's the difference between components and class?
Okay, Omar. So I will have a very interesting diagram today as well. Hopefully this will clarify. When I come to that diagram, and just Umar, let just kind of remind me again. I'll comment on this question again there. But since you talk about it, let me answer it here as well. Is that a class is your very basic fundamental building block, okay? And then it's like your, even lower level is object. So object, then you have classes, then these classes have different, relationships between them and so on and so forth. And then you put these classes, so you all together, it could be like one package, right? And sometimes we classify, you can in your system can have, because it's application specific, so you can have this as a component, or more realistically, you will have multiple packages. So each package will have its own class diagrams in it, classes in it, right? And together they are your components. And you're not able to access this internal functionality except through interfaces. Are we able to visualize this component now?
Yes.
Cool. So again, I said this the other day as well. I'm using the word typical because, about 95% of the time they will be application specific. You can always come up with an example where you will say and argue that, well, this is a component and this is a component which is not application specific. This can be used anywhere in multiple places. So yeah, that will happen. This can happen. But like for example, Google Map, for example, Google Map is a component. It consists of different classes, and it gives you certain interface for you to be able to access those functionalities. But Google Map component can be used in any application as long as you satisfy its dependencies. So yeah, there will be cases where you can argue with me and say that, it's a component, but it's not, application specific. But typically most of the time, it will be application specific because you write these packages, you write these classes eventually at the end of the day to reflect your requirements. Now, if you understand the component, then let's look at what's the connector. This is the second building block of an architecture. So basically what happens is that when you have a complex applications, this means you will have so many different individual components and all of them will be providing you individual functionalities or features. And for you to completely give and satisfy the requirements of the system, they need to interact with each other. And at an architecture level, these interactions are actually your connectors, or managed by something what we call connectors. So connector by definition are architectural building block tasked with affecting and regulating interactions among components. So basically, they are responsible for doing these interactions between components and sometimes they do regulate these interactions. They kind of, make rules about, what can and cannot be shared, how it will be shared, how it will be, the data or the information will be shared among components. So it's more like, if I have to really explain it in another example or analogy, it's more like a pipe, right? And just an analogy here, like it's more like an AC duct, right? And you basically, can have component 1 here, and you can have a component 2 here, and they share data back and forth via this AC duct or connector. Okay, and it is responsible for helping share data and control between these two. Plus, at the same time, it will also sometimes regulate. Regulation could be like, C2 cannot send data back to C1 unless C1 has done so, or so and so forth. So there could be different rules. Now, in many cases, this is a bit of good news here in the sense that most of the cases, the system connectors are, very simple procedure calls or shared data accesses. So they are not very complex. So you can have very simple procedure calls or shared data accesses. But you can also have more sophisticated and complex connectors. So this duct you have between components for help to interact between each other. This could be very simple ones like procedure calls, or this could be really complicated, and you can make up a more sophisticated version of this duct between different components. Lastly, in opposite to components, connectors are typically application independent. So typically they are not specific to an application. These connectors can be used in all different, what we call systems. Any questions on this? Are we comfortable and clear about the basic fundamental difference between components and connectors?
Seems clear.
Seems to clear, alhamdulillah. Now, what are these connectors? Let's look at examples. Your procedure calls, the things you've been using from your ICS 1 or 2 days. They are an example of a connector. Again, you guys, really don't write connectors as such because it's already implemented in your programming language, and you just basically use it. So, and then you can use the procedure call in all different applications. They are not application dependent; they are application independent. You can use the same procedure call to develop an airline reservation system, and banking systems, so on and so forth, a video game, whatever. So these procedure calls helps you connect different components of the system, different packages of the system, and it's inherently developed by the programming language, and it helps you, exchange data and control between components. So this is an example of a very simple connector which we use day in, day out. Another word which we use day in, day out is something what we call shared data access connectors. And basically, they are usually there in forms of non-local variables or shared memory, and software components to interact by reading or writing to this shared location. Can we think of an example from a programming perspective how we really do this?
Database, maybe.
Database, yes. Like a storage in a sense, yeah. Repository, yeah.
Yeah.
The static variables.
Static variables, yes, absolutely. All right. So again, once we define something as static variable, this means, we are now using the connector. Actually, how you go and change the values is via this connector, which is already again developed and is there from a programming language perspective. It's already implemented. All you are doing is basically using it, and it's technically called your shared data access. And in case of database, for example, if you really want to think about your JDBC, ODBC connectors. They are your examples of connectors. You guys have used JDBC or DBC connectors, right?
No.
Not yet.
Yeah.
Inshallah, when you guys are gonna do the programming with databases for sure.
Yes, inshallah.
Inshallah. Okay. So there are two examples. We can have a bit more complicated ones as well. Like for example, you have something called distributed connectors. And all the network applications, all the distributed applications you develop, all different cloud-based infrastructure applications you develop, they usually use something called distributed connectors. And basically they help you couple, usually couple with more basic connectors to give you the connections between the distributors. So you can have like a distributed application through a network, and these applications are now sharing data information between them, these components. And these connectors are called distributed connectors. I don't think from my understanding now, probably you guys have not even tried this one yet, right? The remote procedure calls, RPCs. Not really, right?
Can you give us an example about it?
Remote procedure call is a connector, is an API. It's an API which allows you to basically do a distributed development of applications where basically you have client server infrastructure and use how the data is shared between clients and servers across network. So this API is a built-in API which allows you to do that. Establish remote connections.
Can we say that API is like if I have an application for weather and I use API to retrieve data from website? And
Yes. So that's your connectors. The actual mechanism of getting the data.
Okay.
Right. So this is more like connectors are this part. Right. So the API you use to basically get the information. So distributed this could be an example, the one you mentioned as well. So basically there's something called RPCs, remote procedure calls, which allows you to connect to different database, different client server over the network and so on and so forth. So, and there are many other APIs. So basically they are an example of distributed connectors. And again, I'm pretty sure now you will be able to realize that why they are typically application independent, because the API you mentioned about connecting to the web, getting the web information, you can use it in any application you like, right? So they are application independent. Now, last example for us today is something that we call adapter connectors. And we usually use adapter connectors when we have pre-existing components which may not have been tailor-made for my application. So there are certain pre-existing components and they are generic in nature and they're not really 100% meeting my requirements. Hence, I might have, or they're not compatible with my system. So I might somehow have to write wrappers or glue codes to connect these components. And this wrappers or glue code is basically your adapter connectors. And here, one can argue, because when you're going to write glue code, of course, you're going to write glue code to meet certain specific requirements of your system, right? And hence you can argue with me that this adapter connector is very application specific. That's why we use the word typically, that typically application connectors are application independent, while components are application dependent, because components give you the functionality. Connectors help you connect and share data and information between these components. So far, so good.
Can you give us an example about adapter to connector?
Adapter connectors. Okay, now let's say, for example, let's say you're planning to use Google Map, right, in your application. Now, somehow, due to some reason, Google Maps, for example, gives you coordinates, right? And the way it's giving you coordinate is not, compatible with your rest of the application. And as a result, you might have to do what we typically do in a programming language. We do typecasting, right?
Right.
What we achieve when we do typecasting?
Like Google Map, like give us an integer we want to as a string maybe.
Exactly. So you write some piece of code, and which will make it more compatible with your application. All right, and this is your adapter connectors, which are helping you make it compatible, adaptable to your application. And usually this is done with pre-existing components, because the new components you're going to write them for your requirements anyway. So these pre-existing components typically, they could be written in a very generic way. So if it's not compatible with your application, you might have to write a glue code to help you use them. It's more clear, right?
Yes, thank you.
Perfect. Alhamdulillah. Any other questions before I move to the last fundamental concept on the architecture, and we move into style? Not really. That's good. Okay. The last thing is our configurations, and when these components and connectors are composed or put together in a specific way, right, in a given system architecture, this is more like configuration is more like your Lego blocks, right? So basically you have so you have components and connectors, and when you put them together in a one specific way for your application, this is something called configuration. So configuration, or sometimes we even use the word topology, and we'll be using this word a lot in the next 1 or 2 lectures. So your configuration or topology is a set of specific associations. So they are like specific associations between the components and connectors of your application. So they are very specific way of organizing your components and connectors. For example, you have different components and connectors in this case, and you have put them together in a specific order. This is your configuration. This is your topology for this specific application. So if this is my application A, then this together is my configuration or topology for system A. Again, unlike UML, as I said, last time as well, we don't really have, very strict modeling notations in architectural modeling. Hence, it varies from one tool to other, and so on and so forth. But generally, they have the same thing. I'm pretty sure you will be able to pick from here. What are the components here now?
I think C display manager is a component.
Yeah, C display manager is a component, C app manager is a component, and so on and so forth. And your connectors are these ones, right? And then you have something called like interfaces. These are your interfaces. And topology is that for my system, based on my requirements, C display manager will talk to C troops manager, and C troops manager will talk to data repository and app manager. And this is the topology I have for my application, because this is all about if you look back, it's all about specific associations between components and connectors. So this is a specific association. This is like a configuration for my system. And of course, because these components like state transition diagrams, if you recall state transition diagrams, you can really look at them at different levels as well, because they are too complicated and difficult to draw in one level. Same thing can be happening here, that you can have a high level configuration and then each component can be as complex. Like for example, in this case, the strategy analyzer component is complicated, so you can zoom out or zoom in, sorry, in this case zoom in, and you can even have internal structure displayed as well, internal configuration displayed here as well. All good?
Yeah.
Yes.
Doctor?
Yes, please go ahead, please.
Yes. Is this configuration is it like I'm gonna say, like, if another person wanted to make the same system with the same requirements but a different architecture, does he have a different configuration, or is it like the same configuration as mine?
Okay. Now, if I paraphrase your question, this means when you say different, so there are two possibilities. It's a good question, actually, and this is actually which I was just about to say. Now, see, for a given application's requirements, one of us as a designer can design and put the architecture in this one. So this is maybe option number one. So this is configuration one. For the same requirements, as long as you satisfy the requirements, you can design them in a slightly different way. You can organize these components and connectors in a slightly different way, right? So that will be your configuration 2. Okay. Now, if you're using certain styles, like you say, and we will talk about these styles inshallah in a few minutes. If you're going to use certain style and you say that I'm going to follow client server style, then the structure will remain the same, but different designers can still put them in different, they cannot break the rule of the style, which means that if it's a client server, this means that you will have clients and you will have servers, and clients will not talk to each other. So that rule cannot be broken, cannot be broken. But still designers can still come up with internally, for example, internally they can still come up with different structures, configurations, topologies, right? And this is something we'll be doing it as well, because for a given requirement, two different designers, this is the same as for example, for a given requirements, you can come up with two different class diagrams, right? As long as they satisfy the requirements, they are correct. Of course, one of the class diagram will be better than the others from a design principle, right? So same thing will happen here, that you will have one configuration, another designer comes in, as long as he satisfies the requirement, he can rearrange these components and connector in another different way. It's still a valid configuration from that perspective, but maybe if you do a bit of more analysis, you will say that maybe option B is better than option A. All right, did I answer this question? Is this clear?
Yes, but I have another question now.
Yeah, go ahead, please.
Why is configuration important if it's for each individual will be different?
Okay.
If he thinks like a different way.
Yes. Now, we want to use topology from a style perspective. Is that if we are gonna use a style for our application, and you as an architect has taken a decision that we're gonna use client server style, then this configuration cannot go beyond the rules of the style. Hence, no matter if I have 2, 3, 5, 10 architects, they will still follow the style, and as long as they are following the style, it will not drastically change, right? So the topology will not change. So topology is all about the overall layout of these components and connectors. And the moment we're going to follow these styles, the room of maneuvering is limited, is constrained by the rules of the style. All right. So hence you will, most of the time, from an architecture perspective for a given application, you will have 2-3 options, and then you will select the one which is the most appropriate one for your application. At the end of the day, you will only have one configuration for your system.
So in that case, when I have a similar constraints as somebody else, I can use their configuration if it's like appropriate and it's working good.
Yes, yes, exactly. And this is the whole idea of the styles, is that over the years, people have, for different applications, they have tried different configurations, and they have kind of, shared their experience, and that experience has now been cataloged as part of our styles, some basic styles, and we don't have to reinvent the wheel. Basically, we can, and this comes with, of course, with experience as well, that for such an application, I have probably 2-3 styles which are applicable here, and then you can debate about them, and you can say which are more appropriate for me, and then eventually you take a decision. And of course, it's more appropriate for your functional, non-functional requirements, all of them. Remember, going back to our first lecture, even, these decisions, architectural decisions, are impacted by your non-functional requirements as well. So for a given application A, probably, based on the set of the non-functional requirements, client server might be the most appropriate one. But some very similar application, but based on the non-functional requirements, probably, layered architecture may work. And that's the role of you as an architect, to analyze this, to look at this. So and as part of this course, of course, we'll be covering many other things, but from an architecture perspective, the main message is basically you should know your basic styles as a catalog, and then you should be able to compare and select the most appropriate ones for your application. And by the way, since we're talking about this, inshallah, this is your phase 1 task as well for the SRS I have released. So someone else requirements, you can debate about, what's the best architecture for such an application. Okay, so far so good. Everybody's comfortable with these concepts? Alhamdulillah. Thank you very much. Now, let me stop sharing this one and start sharing the next half. Are you guys able to see the screen now?
Yes.
Perfect. Now, since we understand, alhamdulillah, the basics of architectures, the terminologies we're going to use, we'll be using the terminology of components, using the terminology of connectors, the topology, the configuration. So we're going to now look at styles, all right? And we're going to go through some selected styles. But before this, I need to make sure that we understand at what abstraction level I'm talking about from a style perspective. So when we're going to talk about styles, what exactly level we are talking about, and what kind of information I need to understand about these styles. So I use this diagram. Now look at this one now. I like your special attention for this, because before we talk about these styles and their catalogs and what they are, we need to understand basically what level of design we're talking about. Now, so special attention here, guys. From a scope perspective, if you look, so we have 3 dimensions here, and it's 2 dimensions, but 3 different, classifications or levels. We have the programming level, then we have the application structure, and then we have the system structure. And then from an application domain knowledge perspective or understanding of the requirements of your application or applications, you can have a very shallow understanding of it, or you need only shallow understanding of it, and some For some parts, you will need very deep or strong understanding of your applications. So if you look here, the styles, and I'll just merge them patterns here as well. So architectural patterns and styles, if you look, they are at a system structure level. So they help you define components and their connectors and their topology. So they kind of, it helps you define the configuration slash topology slash structure of your application in terms of the components and connectors. And for you to use or select styles, you need some domain understanding of your application. So you need a, you need a knowledge of your application. You need to know requirements of your system, and hence you will be able to select it. Now, later half of the semester, when I'm going to talk about design patterns, and I'll show you this diagram again. Design patterns are more at a close to a programming level. Okay, so they are more at a class level. They are more at the class diagram level. And hence, you don't really need to know the complete system. You need to know only that part of your class diagram, and you can apply design patterns. While styles, because it's at a structure level, you need to understand the requirements of your application. Is this clear? Okay. Now, since this is slightly beyond the scope of the 316, but since it's here, someone can ask me, what's this domain-specific architectures? All right. Did I talk about product lines with you guys? Maybe very briefly.
No,
I don't think so.
I didn't
No.
think so.
Okay, no problems. Maybe in the other section. So let's say, for example, Microsoft Office, right? When they develop Microsoft Office, so they have Microsoft Word, they have Excel, they have PowerPoint, so on and so forth. Do they have some common functionalities between them?
Yes, like the font and the size of the font.
Exactly. So they have certain common functionalities. And they have some variables as well, right? So PowerPoint has a different, certain different things as compared to Excel, for example, right? Or Excel has an option of writing macros, while the Office, or maybe, maybe Office to some extent, but maybe the PowerPoint does not, and so on and so forth. So when you have suite of systems, right, or maybe enterprise, and I'm going to use this as a loose term here. So when you have enterprises, you have you're working for a company, and that company is using many softwares, right? And they need to be connected with each other. So you come up with something called enterprise architectures, or you come up with something, in case of product lines, you come up with something called domain specific architectures. So this is for a specific set of applications you're developing. And hence, if you notice, it is more at a system level. So it's not an application level, but it's at a systems level. I should put an S here actually. So there, this helps you define the architecture for the systems, for your enterprise. And for this to happen, of course, you need a lot of information about the domain. You need to know what are the different applications I have in my company, and what kind of information they share, and so on and so forth. So we also come up with such architectures which are for the enterprise, and or for in case of Microsoft Office example, for Microsoft to help you develop and write components in such a way that this font component, or this bold italic component functionality, because it's going to be reused, so you don't have to write it again and again. You write it one time as a component, and you can plug in into different applications. All right. Now, this is slightly beyond what we talk in 316, because in 316 we have to talk about packages, designing, class diagrams. We have to also talk about design patterns, construction. So since it's here, I thought maybe I'll give you a bit of idea that, you know, architectures are, this is the basic level of architecture for one application so far we're talking about. But, you know, there are certain things beyond one application. You have enterprise architectures or domain specific architectures as well. You know, usually I spent a bit of time this in our elective course 416, right? But probably will not be talking about them in this semester in 316. But since it's here, I thought maybe I'll give you an idea that, you know, architecture is just not one application. You might have to think about architecture as well for the whole company. Okay. Is this clear?
Yes.
Okay, alhamdulillah. So our focus will be here. We'll be focusing on these ones. Now, more formally, an architecture style is basically what? It's a collection of design decisions. And they are applicable to a given development context. They put certain constraints on the way the specific parts of the applications will be configured, right? So here the word configuration will come here. So they will put certain constraints on the way you will be configuring your applications. In other words, the way you will be organizing your components and connectors. The diagram we saw a few minutes ago. And the reason you do this is that once you follow those constraints, you potentially will get certain properties, certain good quality properties out of the system, right? So styles are a collection of rules people have understood and they have cataloged for us now that, you know, this is, you know, this is that if you organize your components and connectors in this way, you will get certain properties, certain quality benefits, certain, you know, help you achieve certain non-functional requirements or help you achieve certain design quality properties. And they are called your architectural styles. And remember, just moments ago, we realized that architecture styles, you need a bit of information about your application, your requirements, and this is at an application level. So it will help us configure, structure, organize our components and connectors. Now, like programming languages, you know, in programming languages, we have some primitive data types, right? What are those primitive data types?
Integer, double, float.
Exactly. So integer, double float. Similarly, in our architectures, we have some, which I use the words, we have some primitive fundamental architectural styles which have been developed and cataloged by the industry for us. And, you know, except this one, let me, the others are, you know, and they have been further classified, like, you know, the traditional language influenced ones, like they have this style called main program and subroutines. OO has its own structural style. Then you have a catalog of layers category where you have virtual machines and client servers and data flow styles. And then you have shared memory styles and interpreters and implicit invocations and P2P. So these are the basic fundamental architectural styles industry has developed. Again, you know, in my 416 course, I go through each one of them in detail because that course is purely on architecture. Here, I'll be showing you few examples. And if you look at them, I'm going to show these the ones which are in the red now. And I kind of, you know, if you realize, I kind of picked it from different categories, at least one of them. So, you know, from a layered one, we'll be talking about client servers, and from a data flow ones, we'll be talking about pipes and filters and Blackboard and interpreters and event-based and publisher subscribers and P2P. Okay. Let's have a very quick look at component one, right? What's a component and client server? Sorry, the client server architecture style. I'm pretty sure you guys, you know. So, by the way, some of this you might have seen and discussed at a very high level in your 205 as well, right? Probably client server or Blackboard. But here we'll be looking at it, with the keywords of components, connectors, topology, and what kind of data they share and where typically they are used, so that you can make a decision that for a given application, out of these ones, which one is probably the most appropriate one for me. And secondly, important point to also understand is that they are the primitive ones, and sometimes you will just use one of them and it will work for your system. Sometimes for complex applications, you are allowed to mix and match. So for example, the same application will have client server, and within it, for some parts, it will have publisher subscriber. So this is allowed. This will happen. All right. Okay, how much time we have, guys?
2 minutes.
2 minutes.
2 minutes. Okay. So probably I think I'll stop it here. I'll stop it here, and maybe we can talk about client servers and these styles in on Thursday. Let me stop the recording and take attendance.